Okay, this lesson is called number of subsets, and what we want to do is something that's kind of similar to what we've been doing all along. How do we count the number of possible ways of making subsets from a given set? Okay? Now this is in our unit on combinations, but what we're doing here is something slightly different than what we were doing with combinations. So with combinations, we always choose the same number of elements for each of the subsets. We had this notation for combinations that was C and R. So if we had something like C10-2, we read that as 10 choose 2, which meant we were taking a set of 10 elements, we were choosing 2 of them, and we were seeing how many different subsets we could make choosing 2 elements from that set of 10 things. Sometimes we want to do something a little bit different. We want to find the total number of subsets with any number of elements that are possible from a given set. So let's go back to this set that we looked at before, this very simple set A, which just has 3 elements in it, 1, 2, and 3. How many subsets can we make? Well, it's going to depend on how many elements that we want to choose in our final set. So let's consider all the possibilities. Let's say we want 3 elements in our subset. How many ways can we pick 3 elements from this set A? Well, we can think of this in terms of a combination. 3 elements in our set, we want to choose 3 of them. Okay? We could calculate what 3 choose 3 is. Really, there's only one way of doing this. We only have one possible set, the set 1, 2, 3. So there's sort of one possibility if we want a 3-element subset. What if we want a 2-element subset? Well, there are a few different possibilities here. We could pick 1 and 2. We could pick 1 and 3. We could pick, well, I want the curly braces to let us know that this is a set. We could pick 2 and 3. So we've got 3 possibilities if we want a 2-element subset, okay? Which we could have also calculated by doing 3 choose 2. We could have a 1-element subset. Okay? We know what those possibilities are. It's going to be, we could have 1, we could have 2, we could have the set just consisting of the number 3. So 3 possibilities there. And we could have calculated that by doing the combination 3 choose 1. And of course we could have a 0-element subset, which of course is just the null set. How many ways can we pull out elements to get the null set? Well, just one way, because there's only one null set. And that would correspond to 3 choose 0. So the total number of possibilities here, if we add up these numbers that we've got in this column, 1 plus 3 plus 3 plus 1 gives us 8 possibilities. Now, 8 is 2 to the exponent 3. Okay, 2 times 2 times 2. So we had a set with 3 elements. The number of possible subsets that we can make is 2 to the power of 3, 8. Okay? So in general, for a set with n elements, we can make 2 to the power n possible subsets. Okay. Now, another way of thinking about this is for each element in our original set, there are 2 possibilities for including it in the subset. We can include it in the subset, or we could not include it in the subset. Okay. So for our original set A, we got 1, 2, I said 2, but I wrote 3, 2, 3, our possibilities. We can either, in our subset, we can either have the 1 in or out. So that's 2 possibilities for the 1, the 2 can be in our subset or not in our subset, 2 possibilities for 2. The 3 can be in or out. And again, I wrote 3, but I said 2. Sorry, 2 possibilities for the 3, in or out. So by our fundamental counting principle that we did back in Unit 1, our total possibilities are just multiplying all these things together. See if I can put some dots in there. There we go. 8 possibilities. Pretty straightforward. So there's only sort of 2 little tricks that are associated with this concept. Okay? And we'll look at one in this question. How many different sums of money can we make using a nickel, a dime, a quarter, a loonie, and a toonie? So all of the coins that are currently legal tender here in Canada. We exclude the penny because we don't like pennies anymore. So we've got 5 coins. Each one of these coins can either be in the sum of money that we have or not in the sum of money. So the number of possibilities here is 2 to the power of 5, or 32 different sums. Okay. Now the only trick is, and I'll put this in red here, Smartboard's acting up a little bit here. Do we include the null set in our total? Okay? Because sometimes it doesn't make sense to consider the null set to be one of your possible subsets, because it wouldn't make sense in the context of your question. Do we include the null set in this one? Well, let's see. We kind of ask ourselves, is $0, which would be the dollar value associated with not including any of these coins in our tally here, is $0 a sum of money? Okay. Because that's what they're asking us for, to count the number of sums of money. And I think yes, $0 is a valid sum of money to have. Okay? I mean, if I said I had $0, it would make sense. Okay? So yes, we do include it. Now in other kinds of questions where it'll be things like, how many ways can you choose people to go to the library or something like that? There, the null set wouldn't be considered a valid subset because the null set would represent no people going to the library. So if nobody's going to the library, then you've kind of defeated the purpose of the question. Okay? People aren't going to the library. Okay? So just keep that in mind as you're working through the questions in the guide. The last little point. Okay? What if some of the elements in the set are indistinguishable from each other? So we've got a set A here where we've got 2 1s, 1 2, and then 3 3s. How many subsets can we make? We can approach this with the same kind of logic. We want to consider the possibilities, and there should be 2 S's in possibilities, for each element. So let's think about our 1s first. Okay? How many possibilities do we have in our subset for including the number 1? Well, before we just had 2 options. We could have the 1 in, we could have the 1 out. Okay? But now we have 3 possibilities. We could have no 1s, we could have 1 1 in our set, or we could have 2 1s in our set. So we've got 3 possibilities for the digit 1. We could have 0, 1, or 2. What about the digit 2? How many possibilities do we have there? Well, there are only 2 possibilities for the digit 2. We can have 0 2s in our set, or we can have 1 2 in our set. What about our digit 3 here? What are the possibilities? Well, we could have, once again, we could have no 3s. We could include 1 3. We can include 2 3s. We could include 3 3s. And that's the most we could have. So there are 4 possibilities for including 3s in our subsets. Fundamental counting principle tells us that we want to multiply these individual possibilities together. So 3 times 2 times 4 gives us 24 possible subsets.